Hi everyone, this is Mrs. Poland for lesson 6.04 on confidence intervals for categorical data. In this video, I will demonstrate the four-step process for constructing a one-sample confidence interval for proportions. We use this process when we have categorical data and we are trying to estimate the true value of a row, the true proportion. So in order to use this confidence interval proportion, the first step is to define your parameter, specifically rho, the true proportion. The second step is to make sure the conditions are verified. So what are the conditions? They're the same as the ones you used for the sampling distribution of proportion. Specifically, you should have an SRS, or the next best thing, a randomized sample. You need to verify the 10% condition. That's to allow you to use the formula for standard deviation. And then you need the large count condition, and p hat greater than or equal to 10 and nq hat greater than or equal to 10. That third condition allows you to approximate the sampling distribution with a normal model. Notice that we're using p hat and q hat in place of p and q. Why? Because we don't have p and q. The basic format of a confidence interval is the point estimate, which will be, in our case, p hat plus or minus the margin of error. The margin of error is the critical value times the standard deviation of the statistic. Since we don't know p, to get the standard deviation, like normally you would do pq over n for the standard deviation of the sampling distribution of proportions, but we don't have p and q, so we use something called the standard error for the proportions. So it's p hat, q hat, and n. So you're just replacing the p and the q by the p hat and the qn. So we went over in the last lesson how to calculate the critical value. The critical value is based on whatever confidence level you choose. So if you're choosing a 90% confidence level, so a 90% confidence level, then to get alpha, you would do 1 minus 0.9, which is 0.10, and that actually is the area in the tails of the normal distribution, so here and here. Since it's split evenly, when we calculate the z-score, or the critical value based on z, you're going to do z and then the subscript alpha over 2. So in this case, it's going to be 0.1 divided by 2, or 0.05. To get the critical value at that point, what you're going to do is you're going to do inverse norm in your calculator. And again, with the mean of 0 and a standard deviation of 1. And when you do that, you get 1.645. This is a common one, so this is what the value should actually use. Don't round it. So again, there's a four-step process, very similar to the one that you did for the sampling distribution of proportions, just some minor differences. This formula they do give you on your reference sheet. So it's the point estimate plus or minus the critical value times the standard error. So this is your critical value, and this is the standard error of the proportion. Actually, write it like this. Together, the critical value times the standard error of the proportion is actually what your margin of error is. So let's go through an example. And the first problem is set up to mimic this 4-step process. So the first thing we need to do is to define the parameter. Remember, the parameter is not p hat, it is actually rho. And to define it, we actually have to read the scenario given. Sleep awareness begins at the spring with the release of the National Sleep Foundation's annual poll of U.S. sleep habits and ends with the beginning of daylight savings time, when most people lose an hour of sleep. In the Foundation's random sample, notice they give you a random sample of 1,029 U.S. adults, so our sample size is 1,029, 48% reported that they often or always got enough sleep in the last 7 nights. So that 0.48 actually represents p hat. That's based on their poll. So first step is always to gather the information and then define your parameter. So what is the parameter? The parameter is, put your video on hold and write it down, and then we'll go over it. So P is the true proportion of all U.S. adults who often or always get enough sleep in the last 7 days. Next, we need to check if the conditions for constructing the confidence interval for P are met. So put the video on hold and verify the 3 conditions. So the 3 conditions are: random sample is stated. It is condition 2. It is reasonable to assume that there are more than, you would just take the sample size of 1,029 and multiply it by 10. 10,290 adults in the U.S., that's definitely reasonable. This is known as the 10% condition. And then the third condition is NP hat has to be greater than or equal to 10. So you would take the sample size of 1,029, multiply it by P hat. We don't have P, remember, and make sure that both the P hat and Q hat, the number of failures, is greater than or equal to 10. And it is. This is known as the large count condition. Okay. In this step, you also need to have the summary statement, and that summary statement is different than the one we used for the prior unit. So in this case, we have to state that we're constructing the conditions have been met, and therefore we can construct, and you have to actually name the confidence interval. If you don't name it, you actually don't get credit on the AP exam for that section. So this is the summary statement that's probably easiest to use. Since conditions have been met, you're now constructing, and the name of this technique is called a 1 proportion Z interval. So again, you have to have this summary statement. So we just completed step 1 in the process and step 2. And now the next couple of sections, CD, or section C, we're actually going to do our calculations. Let me just get a thinner pen out here. So we want to find the critical value for the 98% confidence interval. Notice it's 98. So I'm going to change markers again. So I'm going to draw my bell curve, and the confidence level is 0.98, so we're looking at the middle 98% of a normal curve. So alpha is going to be 1 minus 0.01, or 0.98 rather, and that's 0.02. And then alpha over 2 is you split that in half, is going to be 0.01. So to get the critical value on the left, and the one on the right, you're going to use plus or minus inverse norm of 0.010, 1. So put the video on hold, and I'd actually like you to calculate it out. You should have attained plus or minus 2.326. So all confidence intervals are based on the point estimate plus or minus the margin of error. In the reference sheet, you can look up the confidence interval. So you would substitute in your point estimate of p hat plus or minus. The margin of error is the critical value times the standard error. So the critical value we just calculated, and then the standard error is the square root of p hat q hat over n. And again, that could be looked up from the table, and that's the standard error of the proportion. So now let's just start substituting into the formula. So p hat is the 0.48 plus or minus the critical value of 2.326 times, and you must show this step, the substitutions into the formula, in order for you to receive credit. So it would be 0.48 times 0.52 over 1,000, what is the sample size again? 1,029. The next step that I would like to see is the 0.48 plus or minus. I actually want to see your calculation for the margin of error. So this arithmetic. So what I'd like you to do is enter this into the graphing calculator, and then I will go over it. So put the video on hold, and please enter that in the calculator. I normally do the margin of error in one step, so it would be 2.326 times control square root. I do control division, and I would enter 0.48 times, whoop, I missed the point, 0.52 and over the 1,029. And I got 0.036. Let me get back to the blue. So now we want to actually calculate the confidence interval, which is 0.48 minus 0.036. That's the lower limit, or the lower bound rather. And this is 0.48 plus 0.036. So the lower bound becomes 0.444, and the upper bound is 0.516. So step 4 in the process is to actually interpret the interval that you just constructed, and we have the sentence frame. We are blank % confident that the interval from blank to blank captures the true proportion of, and I'd like you to fill it in and then compare your answer to mine. We are 98% confident that the interval from 0.444 to 0.516 captures the true proportion of all U.S. adults who report that they get enough sleep in the last 7 days. This is the first video. Go on to the second video and the second problem. It could be found on page 18 or the continuation of lesson 6.04. Thank you.